I'm track and pacer. I am really bad at studying, but my profession requires that I study all the time. So that was a great choice for me. Today, so I'm a network engineer, and to the like 10 people subscribed to me, you're probably already subscribed because you're into network engineering or something similar. So, welcome to this impromptu test stream. Uh, I'm trying to get a decent OSPF lab spun up, and by decent, I mean just not fucked up because I've definitely done some things wrong. I configured this a couple nights ago when I was really tired and should not have been doing it. So I am basically troubleshooting my own issues right now. It's amazing where everybody wants to be. So for this test stream, I'm probably going to do maybe a 20-minute test or something just to see how everything shows up. I do not expect people to join this one. All right. Right now I'm trying to figure out why OSPF 5 is not connecting, not forming a neighborship with OSPF 1. Neighbors with 2, but not 5. Why are we not neighbors with 5? Connected to 5 over 0, 0, 172.2.1.1. Feeling there's something very simple wrong here. That's the problem. We're not in the same subnet, and I'm an idiot. So, actually, while we're at it, debug IP OSPF adjacency. I would like to see this happen. Why can't I type today? All right, here we go. So, 0, 0 needs to be 172.2. 2.1.5, I believe. Whoa. Okay, well that's cool. Whatever. It's doing something weird, even though we didn't have a neighborship with OSPF 1 over the one interface here, but because it's a lab, it's acting weird. And so it actually, before I took it all down, it had been it had elected itself the DR on the link, even though there's nobody else on it. I think it's just a weird lab thing because it definitely did not form a neighborship with the only other router it's connected to. So let's see. IP address 172, and I'm just gonna come over here and double check. So it needs to be 172.2.1.5 is how my addressing scheme is gonna go. 2.1.5. Sphinx Mutiny. Hello. There we go. Route adjust notification up, up. So, here we go. Whoa. I almost never do debug IP blah, 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 blah commands because I don't know if it's like this everywhere, but I work for a provider and a service provider, and like if I ran a debug command on any of our routers, it would just destroy the router. So I would never run that command on anything but a lab device. And I don't know if that's good advice for everywhere or just for me. So okay, it worked. Received packet from 172.2.1.1. That's OSPF 1. Yeah, okay. So this was our original, let's see. I took the IP address off of it and got a notification that we're not on the same network. Well, we already weren't on the same network. It's more weird lab stuff. So, you know, but that's what happens when you have an IP address not in the same network with OSPF. With EIGRP, it's a little flexible. They don't technically have to be within the same subnet for EIGRP neighborship to work. It's better if they are, but you didn't know we could lab like this, huh? Well, welcome to the world of network engineering studying. You have to lab. Yeah, okay. Sphinx mutinies crashed a production switch in their youth or a couple years ago. Yeah, other commands I don't run on routers generally are show run, show tech detail, yikers. That might be a Cisco thing, I'm not sure. Show tech. Arista might also do that. Yeah, the commands that involve like if your router's doing a lot basically and you're asking it, hey, spit all that out in the CLI for me too, it's gonna not be good news. Yikers. All right. That's funny. Remember old DR 5. Interesting. Okay, so anyway, what happened here? I'm so not used to doing the debug packets, but it's so good to do in labbing and I always forget. So we had obviously an issue. Yeah, okay, so I turned on debugging for the adjacency before I actually changed the IP address to the right subnet. So we actually can see we received a packet from our neighbor up here, OSPF1, saying source is not on the same network. So that's pretty good, right? You know, it tells us what's wrong. Same thing. I took off the IP address and we get the same result. What did I do? Take down the address. Here we go. So interesting. So this is all the weird like lab crap that happened. It was its own DR and then it just freaked out because I took the IP address off of it. So okay, whatever. I added the correct IP address onto it and then we can see, okay, the interface went up. Route adjust notification. That's interesting. So it's advertising, hey, my route is up again. I'm advertising this to a communication with OSPF1, which is our quad 1 router ID. Backup scene event before wait timer. I don't know exactly what that means, but I guess I could guess. DR BDR election is happening. So if I remember correctly, and I'm going to look this up in just a minute, so I'm not just lying, but I'm really working on the neighbor states for all the different protocols, specifically OSPF, EIGRP, and BGP, right? So OSPF, I'm pretty sure the BDR DR election typically happens like right after two-way, between two-way and X start. So we'll see if I'm actually right. Okay, so DR BDR election, we elected our BDR as ourselves, all right, because we have the lower router ID, or actually, why did we become? Okay, we're fighting over it. That's what's happening. So that's really funny. Elect BDR quad 5, elect DR quad 1, elect BDR 5, elect DR 1. And we confirm that the DR is 1 and the BDR is 5. Neighbor 1, it prepares for a database exchange. Let's see, we send our, okay, so OSPF1 saying, hey, I'm going to send my database now. Then after that, we send our DBD to 1. Then we receive 1's DBD. We're in X start. We've negotiated things as part of the database exchange and X start. So neighbor negotiation was done. We are the master. That doesn't mean we're the DR. It means we're the master in the database negotiation. So as part of that DVD sending back and forth between routers, someone is also designated like low key, the one that drives that communication, and that's the master of the database exchange. And I do not remember if they're always the master unless like the neighborship goes down or something, or if it's like every time. It would be really stupid and inefficient, I think, if like every time we had to elect somebody the master again. So it would make sense if we stayed the master. So neighbor quad 1 has built their database. We're sending more information to quad 1. We've received a request from quad 1 for some information. We send an update to quad 1. We received another, let's see, we're in exchange state now. Exchange is done with quad 1, and then we send a request to quad 1 again. What is LS? Link state request, I guess. Link state update. So, okay, so basically what's happening with Xstart is we're saying, hey, prepare for a database exchange. We are electing a master of this communication during Xstart. Once that's done, we're into exchange now, and we're exchanging our information back and forth. The master has control of the session. Everybody, I guess, we probably don't have to know the exact details of this crap, but basically, we're talking back and forth and sharing our databases. Finally, we're done with exchange. We send, if we need another request, if we see something in the database that we don't have, then we send a request to quad 1, and quad 1 will then reply with an update for us. And then once our databases are synchronized, we're in full state, which is stable, and that's what we want. And I'm cheating a little bit because I want to double check. Yeah. So, yeah, okay. So, with a link state routing protocol like OSPF, every router in the same area has the exact same link state database. They do see themselves as the center of the world, so they're the root or the top, depending on what you want to, how you want to think of it. They're the root of their own SPF tree, for the algorithm that's used to calculate costs and things, because that's necessary. You have to know where you are in the scheme of things, and you're obviously your root. So they think of themselves as the root of their trees for the purposes of the algorithm, but they have the same database everybody else in their area does. So fun. Loading is done. We're in full. Why are we having a neighbor change event here? This is weird. This might be just some weird lab stuff. I don't know. But as long as things are stable, we shouldn't be having like a uh, a DR BDR election every like 10 minutes. That's weird, but I'm going to choose to ignore that crap for now. Okay, I'm just going to make sure that OSPF 1 has all its neighbors. Do I want to look at packets? That's going to be a lot of stuff, but I want to see everything for now. Probably going to get annoying. Yeah, going to get annoying fast. So out 0/1, we're sending hellos, it looks like, or something. OSPF 1 packet. Yeah. Yeah, we're sending information. We're sending probably hellos out. 0/1 is connected to OSPF 2. I think the rest of this OSPF is good. It was just router 5 that wasn't. It's not working. Should have 2 neighbors on OSPF 2. We only have 1. Okay, so we have a problem with connectivity between 2 and 3 as well to troubleshoot. Wow, this is gonna get annoying. Okay, debug. No. There we go. Debug IP OSPF adjacency for now. We'll just have adjacency on. Okay, so we're doing okay with OSPF 1 and OSPF 2, but now 2 and 3 are not properly in an adjacency. Go IP protocols. Okay, I just haven't set up fucking OSPF. That makes sense. Yeah, OSPF. Who was saying Pilgrim? Welcome to the most boring stream on Twitch. Me configuring OSPF in the lab. Okay. H. Yep. I'm just double checking. I have my IP addressing scheme over here. Okay. OSPF 3, so 0/0 is going to be on the same subnet as OSPF 2 0/1. So we're doing, all right. GI00, IP address is going to be 172.3.1.3/24, no shut, interface GI01, IP address 4.1.3. Okay. Shut, we'll leave it there for now. And OSPF 4 maybe doesn't have OSPF on it either. Maybe I just completely hallucinated configuring OSPF on these two routers. It is entirely possible. Show IP protocols. Yep, no OSPF. Awesome. So my interfaces configured. I do have my interfaces configured. Okay. 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 Then I really just need to hang on. Debug IP OSPF adjacency. Could I copy and paste this? I absolutely could. Will I? No. All right, there we go. So I need to configure OSPF still on router number 3 and router number 4. But before I do that, actually, I have already done the basic OSPF configuration on 3 routers, and I'm really tired of it already. So I might skip over. I have a book that I'm looking through over here just to get familiar back into it, because point to multi-point, I don't really want to try and do that in the lab. Point to multi-point, completion frame relay. Fuck frame relay, I'm not doing that shit. I will just lose points on the test. I don't even care. Does not use a DR for the OSPF. Multi-point, okay. The OSPF network type loopback is enabled by default for loopback interfaces and can be used only on loopback interfaces. The OSPF loopback network type indicates that the IP address is always advertised with a /32 prefix length, even if the IP address configured on the loopback interface does not have a /32 prefix length. So it's good to know. Boop, 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 boop. Timers 10 and 40 by default. Authentication. What happens when I configure authentication? That's something I haven't done yet. Let's try that. Let's fuck something up. Okay, so 2 types of authentication. We can do plain text and we can do MD5 hash. So what are my commands? Area such and such authentication, blah, blah, blah. Interface parameter command. Let's see. OSPF authentication is enabled on an interface by interface basis or for all interfaces in an area. Okay, actually, OSPF 2, I'm pretty sure I have in a different area. That's why I only configured 1, 5, and 2, is because they're all going to be in the backbone, but starting at 2, 3, and 4, I think we're going to have at least 2 more areas. So IP protocols, OSPF 1. Yeah, okay, so we have 2 different areas here. So my loopback on OSPF 2 and 0/1 going to OSPF 3, those are in area 1. So gonna have to remember that. Okay. Anyway. Yeah, fuck it. All right, we'll do global OSPF or all interface. authentication with MD5 because I'm not a fucking idiot. Why would I ever configure plain text? I guess I should learn to like recognize it, but come on. Thank you for the good luck. Have fun. Thanks for joining. Let's see. IP OSPF authentication. Let's see. All right. IP OSPF 1. Nope. Router OSPF 1. Come on. Let's see. Area 0. Authentication message digest. You know what I hate about this is that you have to type out message digest. With EIGRP, guess what? You just have to type MD5. It's fucking stupid, OSPF. What is this? Okay, that's it. Does it fuck things up? Hmm? Ah. Oh, okay. I guess I should have generated a key. Whoops. I definitely should have. Let's see what happens when I do. Let's see. I can generate a key on the interface. MD5 password. Okay, so actually, interface GI00. IP OSPF message digest key. 69. MD5 bracket pacer. Nice. Now what happens when I only have one interface in a neighborship? Why are you sending with key 0? It. Nope, that's not right. Okay, let me just see what happens on OSPF 1. Interface 0, 1. I'm going to do this interface. OSPF authentication. Message digest. IP OSPF message digest key. 69. MD5. Bracket pacer. Come on. Mismatched authentication type. We use type 2, type 0 and type 2. This is interesting. I'm learning something new. I have no idea what the fuck is going on, but we'll figure it out. Show runs section OSPF. Oh, Jesus Christ, what's happening? I don't know if I can cuss on Twitch, so like, I'm sorry. Video might get taken down. So for some reason, the other side's using packet type 2, and we are using key 0. Type 0. Yeah. Come on. My question is, oh, come on. Did this affect neighborship? I'm not sure I saw neighborship go down. So we're, oh, it did affect neighborship. Show OSPF database? Curious. Okay. So we're getting something from you. Sometimes I just can't tell if stuff is like weird lab shit or if it's actually like how it would work in real life. And that's supposed to be what a lab helps you with, right? Type 2. How do I look up information about the key? All right, it's time to go Googling. Hang on. Do 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 do. OSPF. Physical white papers. IP OSPF authentication. MD5 authentication. IP OSPF message digest key. 69 MD5 track paper. It should work. That's what 0. 3 different types of authentication supported by OSPF. This I didn't know. So null authentication is that type 0 that apparently we're using on OSPF 2 router. Plain text is type 1 and MD5 is type 2. So type 0 means that there's no authentication, basically. It's the default. So for some reason, so it looks like OSPF authentication is working okay on 1, but on 2, we have a problem. Hmm. But I know I have it right here in show run. What have I done? You've only done it interface by interface, huh, Sphinx? That's cool. I'm just trying to do it every single way so I at least have a cursory knowledge of how to do it for the test. This probably won't even come up. Just watch. I'll study this all night. Won't even come up. So what am I doing wrong? Sorry, I'm looking for white paper real quick. So, okay, they have an example of an interface by interface authentication. Zero authentication message digest. See, I have message digest key. Maybe the book is somehow wrong. And you have to configure it on no OSPF. All right, fuck it. Let me just configure it on the interface and see if that fixes it. Message digest key. Whoops, track it pacer. Nothing's happening. That might be good. But our neighborship still hasn't come up. Have I done something weird? 1.1.0. Hang on. Oh, God. That's the problem. Aha, I figured out my own incompetency. So I configured, well, I think I did. I think I did. I'll just say that I did configure it. You see right here, area 0 authentication message digest. And, well, hang on. 0/0 is 112. 112 is in area 1. Yeah, and I configured MD5 authentication just for area 0. Oh, come on. Just want to see if maybe I'm just fumbling around in the dark, okay? Oh, you gotta be kidding me. Wait. What's really fun about watching someone lab shit up is that you get to watch them do like 5 million typos. God, you show run action. Not EIGRP. IP OSPF. Nope. Area 0. Okay, it's under the router. Yep, 1. There we go. Hey, hey, hey. We're back up. Real-time troubleshooting the problems I cause for myself. All right, so that was pretty simple though. They need to be in the same area. If you have one, okay, so neighborship's not going to come up if you have authentication configured on one end of link and not on the other. One neighbor and not on the other. So with that in mind, I have area 0 set up for authentication. I don't want to deal with that actually. So there's just a fun little thing here. OSPF 1. No. What was it? Area 0. Authentication message digest. No, thank you. I have 2. 0. Make sure it's not on 0, 1. Yeah, okay. Do that. Oh, come on. All right, now we don't have to deal with authentication in area 0. Okay. Getting back to it. Okay. A book somewhere. Here we go. All right, so that was pretty much basic OSPF. No one really saw me do much of it except for the authentication stuff, but that works. All right, I'm looking through advanced OSPF just to see what I can figure. Let's see. Link state database fields, show IP OSPF database router. Okay, so here's where we're getting into the different types of LSAs, which is really good, actually. Show IP OSPF database router. So, yeah. All right, you know what I need to do though, in order for this to actually work, I do need to configure OSPF on these other two routers. I didn't want to, but I have to. So let me get that done real quick. Don't look as I struggle. Yeah. I spent like 10 hours last week just configuring basic EIGRP, and I'm pretty sure it scrambled my brain. That's the only thing I want to configure now in my brain. What are we in? Area 1? Network. And network, what are we doing? 172.4.1.3. Hey, neighborship, hooray. Uh-oh. Matched area ID. Ooh, I fucked it up. I fucked it up. Interesting. 3.1.2 should be in area 1, but it looks like I configured it as not area 1. So let's see. 3.1.2, show IP OSPF interfaces. It's going to be in area 0, isn't it? Nope. Brief. Yeah. Oh, you know what? No, I'm stupid. This is area 0. Okay, so this is really funny. So let's see. 0/0, we don't have any neighbors, but because it's a lab and there's weird stuff going on, I guess we're still we're still going through the DR BDR election with ourselves anyway. So our backup router is just quad zeros. Oh my god. Okay, anyway. Uh no network. Let's see. Do show runs section. Let me just undo what I've done here because I obviously don't know what I'm doing. No network 172.3.1.0. Everything on OSPF 3. Oof, there you go. Network. Pretty sure everything on this route, maybe not. Almost everything on this router is going to be in area 0. There we go. There we go. There we go. Yes, 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 yes. Go, 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 go. Beautiful. Okay. Here we go. So what terrible sin did I make? So I set area 1 to my 4 dot interface, which is what's facing OSPF 4. You know what? So area 0 I think is going to be in between 2 and 3, and I think I'll do one other area. So not area 1 obviously because that's over on the other side of OSPF 2, but I'll do area 3. Or sorry, I'll do area 2 between OSPF 3 and 4. So no network 172 blah 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 blah. Let's take this out. And instead we'll do, oof. Instead we'll do area 2. There we go. And now here comes the flood of, there you go. Oh, there's not going to be a whole election. Probably. Not with OSPF 4. It might elect a BDR and a DR on its own. Actually, yeah, it already has done that, hasn't it? God. Okay. Okay. Well, we should at least be in a neighborship with OSPF 2. Nope. Yep. 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 Okay, cool. And now it's OSPF 4's turn. Hopefully I can actually configure basic OSPF this time with like not too many crazy mistakes. Okay, so router OSPF 1. So what did I put it in? Area 2, right? Area 2. Okay. Do show IP interface brief just to make sure. Yep. Okay. Network 172.4.1.0/24 area 2. Okay, let's see if this works. There we go. There we go. There we go. Yes. Beautiful. Routers are fast, man. Okay. I think we're good now. 8. You know, it's weird. BDR election. You know, at first I thought it was doing 2 different elections, but it's talking, it starts the election, it talks, it talks, it talks, it talks. No, yeah, and then it does, yeah, it is doing 2 for some godforsaken reason. I assume that that is not normal and this is a dumb lab thing. So we had an election here and we're having another election here. Every single router's done this, I'm pretty sure. But whatever. Okay, we're good. All right, onward through advanced OSPF. I'm reading out of the NRC official certification guide, by the way. Let's see. The CLI is a little bit annoying to deal with because it is so short. And this next command is going to be so much. Show IP OSPF database router. Okay. So we are quad 4. Router link states in area 2. 88. So we're getting in LSA from 3 quad 3s, which is OSPF 3. We are an area border router. Or rather, OSPF 3. That makes more sense. OSPF 3 is an area border router. Transit network designated router address is 3. I forget what this is. Router interface address, link data. There's something fancy here that I'm gonna have to remember, but let's see. And then, of course, we have our own stuff for some reason. Is that normal? No, okay, it looks like this is not normal. So we do have an LS link state entry in here from ourselves. And from what I'm seeing in the book, that's not normal. What do we call ourselves? Let's see, advertise area border router. We're not an area border router. Interesting. I mean, whatever. It's a weird lab thing. Okay. The initial fields of each type 1 LSA are the same. If a router is functioning as an area border router, an autonomous system border router, or a virtual link endpoint, the function is listed between the length field and the number of links field. So between these 2 fields. So we're not an ABR or an ASBR. However, our neighbor is an ABR. So it's listed right here between length and number of links. Okay. Let's see. Each OSPF-enabled interface is listed under the number of links for each router. Each network link on a router contains the following information in this order: the link type, the link ID, the link data, and the metric for the interface. Okay. Okay, cool. Let's see. During the SPF tree calculation, network link types are one of the following. We can be a transit link, which a transit network just means that we have an adjacency formed and that there was a DR on the link. A point-to-point link indicates that an adjacency was formed on a network type that won't be using a DR or BDR election. Interfaces using the OSPF point-to-point network type advertise two links. One link is the point-to-point link type that identifies the OSPF neighbor router ID for that segment. And the other link is a stub network link that provides the subnet mask for that network. Interesting. No time. There's a DR. Maybe I should set these as point-to-point links to take a look at it. Mm-hmm. How do you do that? Let's find out. How do I set you as a network? There it is. Network, and then it would be point to point. And our neighborship went down. Oof. Oof. We're not having fun. Our neighborship went down, and then we promptly formed a neighborship with ourselves because, again, lab. Terrible. Okay, and I'll do the same on OSPF 3. So interface 201 IP OSPF network point to point. And hopefully our neighborship will, yep. Nice. Okay, and we're back at it. So let's look at what the link state database looks like now, maybe. Or at least for LSA type 1. So okay, again, point-to-point links indicate that an adjacency was formed on a network type that doesn't use a DR. Interfaces using the OSPF point-to-point network type advertise two links. One is the point-to-point link type that identifies the OSPF neighbor router ID for the segment, and the other link is a stub network link that provides the subnet segment. Oh, hang on. So let me do that again so it's not broken up. Okay, so here we go. This is what it's talking about. So we have two links being advertised now. That's confusing, you know? Because if you're troubleshooting something and you're expecting one link and you see two, you're going to be confused. But okay, since it's point to point, we're advertising two links. We have the point to point link being advertised with the neighboring router ID of quad 4s, but we are on quad 4. Interesting. Oh, I see. Sorry, I'm an idiot. So this is an LSA from OSPF 3. So in OSPF 3's update, it's saying it has a neighboring router, which is us, quad 4. It has its own router interface address. I don't know what this is. MTID metrics, no idea. Also, don't remember what that is. Then we have the second link, just as the book said. So we're advertising our network and subnet number, and then below it we have the link data, which is the network mask or /24. Good night, Boomer. Thank you for joining. Yeah, I am not looking forward to the NSSAs. That's actually my least favorite. I don't want to do it. Okay. Anyway. Boom. Yeah, okay. So we're also, for some fucking weird reason, I hate this. I hate when a lab is supposed to show you real world stuff, but I mean, this is virtual, so whatever. I'll take what I can get. Maybe it's Cisco Modeling Labs. I don't know. Eventually I'll get Eve. Please, no one give me shit for not having Eve, please. Okay, lastly, we have a third network type. So network link type, rather, not network type, but link type. So we have transit, which just means a DR, BDR election happened and it's the neighbor adjacency happened. Point to point is that one where we just looked at with the two links, stub and the just regular point to point. And then the last network link type is actually just stub. Indicates no neighbor adjacencies were established on that link. Point-to-point and transit link types that didn't become adjacent with another OSPF router are classified as a stub network link type. Point-to-point and transit link types that didn't become adjacent with another OSPF router are classified as a stub network type. When an OSPF adjacency forms, the link type changes to the appropriate type. Oh, okay. That's tricky. I can totally see Cisco asking that question. Okay. Uh, boy. Okay. So that was just router LSAs or the type 1. So we're going to run the same command, but link. No, it's not link. We would just have to do database. Oh, it's network. Never mind. Yeah, okay. A type 2 LSA represents a multi-access network segment that uses a DR. The DR always advertises the type 2 LSA and identifies all the routers attached to that network segment. If a DR hasn't been elected, a type 2 LSA is not present in the LSDB. So that's our situation here, actually. But I bet if I go over here to OSPF 1, where I didn't make anything a point-to-point network, whoops, I bet we'll see something. Yeah, so this one does have network LSAs because there is a DR on this segment. Let's see. The DR always advertises the type 2 LSA and identifies all the routers attached to that network segment. I'm pretty sure OSPF1 is a BDR, so hopefully we have. Does it tell us if it's a BDR here? Or like, okay, anyway. If a DR hasn't been elected, we don't have a type 2 LSA. Type 2 LSAs are not flooded outside the originating OSPF area in an identical fashion to type 1s. Let's see. All right, cool. Show IP OSPF database and network. All right, advertising router here. All right, whatever. Let's see, database network. Now we're gonna do summary because that is type 3. Okay. So type 3 LSAs represent networks from other areas. The role of the ABRs is to participate in multiple OSPF areas and ensure that the networks associated with type 1 LSAs are reachable in the non-originating OSPF areas. That was a lot of words. So it's a summary of other areas, basically. So our ABRs are the ones that participate in multiple areas. That's why they're ABRs. So they're the ones who are responsible for using type 3s and telling all the routers within the area that aren't ABRs about other areas with a summary. So when an ABR receives a type 1 LSA, it creates a type 3 LSA referencing the network in the original type 1 LSA. The type 2 LSA is just used to determine the network mask of the multi-access network. The ABR then advertises the type 3 LSA into other areas. Okay, so we receive a type 1 LSA from like on OSPF 2 because that's technically our ABR. We receive it from OSPF 1 or OSPF 5. Well, actually, no. Let's see. Yeah, no, whatever. Anyway, we receive our type 1 and we create an LSA type 3 with it and send it on to OSPF 3. If an ABR receives a type 3 LSA from area 0, it generates a new type 3 LSA for the non-backbone area and lists itself as the advertising router with the additional cost. A lot to lab up, and I don't know if I want to. Okay, um, I can actually tell I'm still learning Twitch. Okay, I've got like a few viewers. Anyway, thank y'all for joining me. It's been about an hour. I'm gonna stop now because I need to read some stuff and it'll be very boring to stream that part. So, thanks for joining me on this first horrible Twitch stream. There will probably be many more. I'll see you guys later.